Today we're on lesson 11-3 vertex form, page 186. We're going to be looking at writing quadratic functions in vertex form. So the functions that we're going to be given today are in standard form. Remember, standard form is that ax squared plus bx plus c. So we're going to learn the steps to rewrite this so that we can easily identify transformations. And we're going to rewrite it in what's called vertex form. So over here on the side, before we get started, let's look at this math term box. So vertex form is when we have an equation in this a parentheses x minus h squared plus k. This allows us to identify the vertex, which is that min or max with a parabola, as our h comma k. To do all these steps, we're going to need to remember completing the square. Remember, part of completing the square is take that b value, the number with the x, divide it by 2 and square it. That's the steps you do every single time with completing the square. B divided by 2 and square. So let's look at an example. So right here we have 3x squared minus 12x plus 7. So first thing we need to do is kind of group those two x terms together, the x squared and the x. So they have a GCF, and we want to divide out that GCF, and that's 3. Basically, it's going to be the leading coefficient. The number in front is what you divide out. So divide them both by 3. So when we divide them both by 3, the 3 goes in front, and we're left with x squared minus 4x. And that plus 7, that constant, is just hanging out at the end, not parentheses. So our b value is negative 4, so we complete the square. We divide it by 2 and square it, and when we do that math, we get 4. So this 4 is what we put inside the parentheses here. But notice, we're not just adding 4. This 4 was inside parentheses, meaning that it was 3 times 4. Well, 3 times 4 is a 12. So really, when we just put a 4 here, that's really adding 12. I made that note over here on the side. We're adding 12. Well, we can't just start adding and subtracting different numbers to equations. What we do in one equation, we have to do a zero pair of it to cancel it out. So if we add 12 here, we need to do its opposite, subtract 12. So outside the parentheses with that constant, we need to do the zero pair, so subtract 12. So notice we have negative 12 plus 7 gives us negative 12 plus 7 there, which would give us a negative 5 as the constant. Inside the parentheses, we had x squared minus 4x plus 4. Well, that is a perfect square trinomial, meaning if you tried to figure out what numbers multiply to get 4, add to get negative 4, we get x minus 2 and x minus 2, or x minus 2 squared. Notice the 3, that leading coefficient, is just hanging out in front of those parentheses. So right here, this is our final answer, and this is in vertex form. This allows us to easily identify transformations, because notice that 3 means vertical stretch by factor 3. The x minus 2 means we shift right 2. The minus 5 means down 5. And the vertex, that minimum or maximum, in this case would be a minimum, would be 2, negative 5. So let's look at a couple more examples. So first thing we need to do here is we start with the standard form. We need to look at those first two terms, the x squared and the x, divide by the leading coefficient. In this problem, the leading coefficient is the number in front of your x squared. It's 5. So we need to divide both of these terms by 5. 5x squared divided by 5 is x squared. 40x divided by 5 is 8x. Now, your b value is 8, so you need to complete the square on this. You need to do 8 over 2 and square it, which is 4 squared is 16. So right here, inside the parentheses, we put a 16. But we're not just adding 16. This is inside the parentheses. We're doing 5 times 16. 5 times 16 is 80. So we're really adding 80. So if we add 80, we need to also do the opposite, or subtract 80. So over here with that constant, we need to undo the addition of 80 by subtracting. So now, inside the parentheses, we have x squared plus 8x plus 16. And outside, with our constants, we have the negative 83. The 5, that leading coefficient, is just out in front. So right here in parentheses, this is a perfect square trinomial. We can easily solve these by figuring out what multiplies to get 16, adds to get 8. It's going to be the same number because we're going to get the same factor. so that we can write that factor raised to the second power. So we get 5, and then parenthesis, x plus 4 quantity squared minus 83. So now that it's in vertex form, this is our final, we can identify the vertex, and we can also identify all of the transformations, the vertical stretch by 5, the shift left 4, and the shift down 83. Okay, let's look at one more example together before you're going to do some. So in part B, first, tell me, what is the leading coefficient? So notice the leading coefficient is -4. That's what you need to divide by. You divide both the x squared and the x term by 4. So when we do that, notice we're left with x squared plus 3x. Again, the -4 is out in front. So with that b value, and that b value is 3, we divide by 2 and square it. It's 9/4. So we put 9/4 inside the parentheses. Don't worry about the fraction. It'll simplify out nicely in just a second. So we're not just adding 9/4 here. We're really doing -4 times 9/4. Well, if you multiply -4 times 9/4, the 4's end up canceling, and you're just left with -9. Well, the opposite of -9 is a +9. So now we have -4, our perfect square trinomial, and then our constants are 1 plus 9, or just 10. So this perfect square trinomial. Now, hopefully you've started seeing a pattern with the trinomial. I've also tried to highlight it in purple. Notice, when you do the b value divided by 2, like looking back over here at a, that is your factor. Same with over here, b value divided by 2, that is your factor. If we go back up to this example that was written in our book, notice the b value divided by 2 was -2. Notice in our factor, it was x minus 2. That b value divided by 2 tells you your factor. So if you get fractions, don't worry about it. Just look at what was the b value divided by 2, and that will give you the factor there. So we have the factor squared and then plus 10. So this tells us the 4 transformations: the reflection, the vertical stretch by 4, the shift left 3/2, and the shift up 10, and also our vertex point. So now I want you to try some on your own. So on the top of the next page, I want you to try this first one, -2x squared plus 4x plus 3. I already have it graphed for you, but first I want you to divide by the leading coefficient, complete the square, and write it in vertex form. Okay, so that leading coefficient was -2. So when you divide it by -2, we were left with x squared minus 2x. Take the b value, divide by 2 and square it, so we get a 1. So we put a 1 right here in parentheses. But we're not just adding 1. We're really doing -2 times 1, which is a -2. The opposite of -2 is +2. So we make sure we put that 0 pair. So when we simplify this, we have -2, our perfect square trinomial, and then our constants. The 3 plus the 2 is the 5. Remember, the perfect square trinomial will factor to the same factor twice, or factor squared. If you have a hard time factoring, just look back at what was that value when you did b divided by 2. Like in this problem, it was -1, so the factor is x minus 1. So now in this problem, we can identify all the transformations: the reflection across the x-axis, the vertical stretch by 2, shift right 1, and up 5, which we see in our graph. So let's try the next one. So there it is in standard form. Don't let the fractions freak you out. Just divide by that leading coefficient. Do completing the square, and you'll get it in vertex form. So that leading coefficient is 1/2. Don't let 1/2 freak you out. When you do 1/2 divided by x squared, you get just a 1x squared. When you do 3 divided by 1/2, I have it written over here, 3 divided by 1/2 is just 3 times 2 is 6, 6x. That's your b value. Divided by 2, square it, get 9. Put the 9 right there. Well, this is 1/2 times 9, or 9 over 2. It's a positive, so its opposite is negative. You factor the perfect square trinomial, or you can just remember what's that b over 2 value, however you want to think of that. The constants over here, this is 3/2 minus 9/2. That's negative 6 over 2 or just negative 3.